So yeah, previously this is the sort of thing that you just see. You just see a sort of a green-red model, and then you get your maximum inside deviation and the maximum outside deviations on the left-hand side. But now we have got this probe tool, which allows you to actually click an area on the model and actually find out what the value is at that particular point. So we can see there it's 0.1. If you do want to add multiple probes, you can add hole control and just add different hole control and basically click around the model to get multiple probe points and find out the deviation around the model on that exact spot. So that's a really nice feature. Obviously, if you want to then use those images and anything, you can right click and use the copy scene tool and copy those into your, I don't know, a Word document or an email. You can use that copy scene tool, or literally just use your Windows sort of snip tool. So it will work on SDL and SDL, and it will also work on model and model if you're looking to compare two models and they might have map changes made to them. So that's one of the first new features, quite nice. Same sort of similar sort of feature also does work on the draft tool. Let's have a look. So I could actually show you on this model, but I'm going to open up a new one. If we use our draft tool on this model, on this part, I might choose a pull direction if I can find my ZT, which might not be showing. 2 seconds. Global world origin, it is. Oh, that's right in front of me. So yeah, so using the draft tool, you can click on our parts, and I can change my pull direction to the Z, which already is. And then we can see obviously where the 0-degree draft changes on the part, obviously the red and green line, but we can also then add probe points again and see what the actual draft is like on this location. So you can see here, I can hold in control again, take multiple points on the model and find out what those actual values are at a particular point. So those are 2 new features in the measure tool, in draft and deviation tool, and they will hopefully help a few people, especially people who are doing reverse engineering or wanting to see changes between models. The next thing that I'm going to show you is, as Peter mentioned in one of the slides, is the this AutoConstraint tool. So one thing that is quite useful if you're importing 2D data. If you ever import 2D data into SpaceClaim, obviously it'll just be lines and arcs and curves. But you can actually auto-constrain that data and add constraints to it. So if I actually drag a DXF in this instance into a model, pretty basic DXF, but I just want to show you how you can, one, use this the sketch constraints tool. And so I've imported my DXF into SpaceClaim. If we right click on the plane in the structure tree, you'll see that whenever you've got a plane that's got sketches on, you have the option to resume sketching, and that's really important to obviously right click on it and say resume sketching, because that'll activate these sketches that are on that plane, and then you're able to use the auto constraints. So at the moment it has no constraints. If I tick the show constraints, you can see it hasn't got any. But I can actually tick the auto constraint after I do the whole model, let the software auto constrain it. But you do have your options on the left hand side, like for example, if I only want to apply parallel constraints, you just make sure parallel constraints are ticked. But then hit the tick box, and we can see our constraints have been applied. We can have a look what constraints have been applied to this edge. We can see 2 parallel constraints. If you actually click on a curve and hover over them, you can see where those constraints have been applied. So that's just a very quick one on auto constraints. Another one, just in terms of sketch-based constraints, if people are using them, I find the best way to use them is that some people are finding that once they create a sketch, that they can't go back to the sketch once it's been created the surface. So I might want to create a sketch on a new plane. I don't want this to interfere with this plane. So I click on this plane and I go into sketch mode. I then create a sketch. It's just going to be a block. And one thing I like to do is actually sketch with layout sketches. So I'm going to create 2 shapes, with one with layout sketch ticked, and we can see that there. So literally 2 boxes. If I want to end the sketch editing, This one that wasn't created with a layout sketch is created, gone straight to a surface, as we'd expect in SpaceClaim. But previously, you could select on that surface and go back into a sketch mode. But obviously now, if we click on that surface and go into a sketch mode, it stays as a surface. So layout sketches are quite nice because they don't turn into surfaces unless you specify them to. And you can always right-click on the plane and resume the sketching and modify that sketch if any if needed to be. So just wanted to show you that in terms of working with sketch constraints. The next thing I will open is just to show you this very quick. If anyone's working with sheet metal, we can, let's have a look, mitered corner. So this is how mitered corners were previously created in SpaceClaim. So you can see this corner condition here, quite open, would have needed a weld or more of a weld. If we unfold it, we can see the results that we get in these corners. In the new version, or this version, 2021, if I create a model, and to create a mitered corner in sheet metal, you are just selecting on two edges and making sure you, as you pull them, you can see the mitered corners are getting created. And you can see in this version, the mitered corners are a lot closer, a lot more uniform. And when we unfold it, you can see that there's less gap between them. Obviously, the bottom one, we can change that ourselves. That corner condition can be changed to whichever corner condition we like. Laser edge, for example, and those can be modified on the fly. So that's the sheet metal one. The next one, something that Peter did mention, was Toolbox. You got some of you may already be using Toolbox. If you're not using Toolbox, please let us know, and you're interested in it, please do let us know, because it's a great app. We have sent it out to customers in the past, so you may already have it. But if you haven't got it, just to give you a brief example, very quick example of the Toolbox app. So this is just a very basic example. Just got a component, and I would like to apply some bolts or something to these holes. So I can either do them manually. So when you get the Toolbox app, you will also have a Toolbox module appear here on the left-hand side near your options. So you can, if you just want to select an individual hole, you can literally just click on an edge and choose your size that you wish, choose your type, and the length of the, and you can see you can choose a length, like that's 30, I can actually type in a length there, so like 20, and numerous other settings, and basically click insert. So I'm just going to apply a bolt at the moment, I'm not going to apply a washer or a nut, and if you get an error, so you can see my length is actually shorter than the stack-up length of this component, you'll get a little message warning you. So I could cancel that and actually just type in 30 or whatever length it needs to be. And we can see, oh, has actually applied also a washer locking nut on mine as well. So that's this set here. If you wish to apply one to, let's just choose that. If you wish to apply one to all these holes, so you might have multiple holes, the way to do that is if you select on one of the edges and then hold Alt and select on the face. So you hold selecting on the edge of a hole, selecting on Alt on a face, and that will basically allow you to apply to all of these holes along that face. Again, just you've got your settings on the on your Toolbox module here, and you can set all this up to add in whatever you wish. And again, pretty much just hitting the insert tool, and it will apply to each of those. So with this one, it looks like we've got, in this instance, clamping distance, we've got nut options and side washer options, and it will apply those and put them into components on the left-hand side. These can all be obviously neatened up and moved to a new component, maybe nuts and bolts, that sort of thing, just to tidy up your tree on the left-hand side. So that's the Toolbox app. As I say, if you haven't got that, you can download from the App Store, or just let us know, and we can always direct you to the right location to download that. last one that Peter showed was the deviation tool if you're using facets. So I'm just going to open up a file. I'm going to drag and drop it from Chrome. So this is, I'm just going to hide a few of these, just a few STLs. And the deviation tool in here is in the facets tab, so it's the regularized tool. So a lot of you will have the facets tab now available. So it is in the regularized tool. And you basically click in this tool. Previously, you didn't have the option to set a deviation or this option to make it curvature dependent. So as Peter mentioned, it would just apply a uniform, depending on your max edge length, size, all around the model, and which might not be that great of a result depending on what sort of model you were looking at. So in this instance, I'm just going to choose my pass, which is this. You can see it's trying to define me a max edge length here of 34. I don't want that, I want 5. I'm going to make it curvature dependent because I don't want it 5 mil all the way around. And I can hit the tick box. And hopefully you can see that the triangles aren't all the same length. So in areas of high curvature, the triangles are going to basically be smaller. In areas of low curvature, the triangles are going to be larger. So that's you're regularizing it based on the curvature of the part. Another tool you can use is, if you don't want to use max edge length, you can use deviation. So you can basically say, okay, I want it to no more deviate than a millimeter from the original model. So you can use deviation as well. And that is a few of the new features in SpaceClaim. As I say, there are a few more. Best place to see all the new features is in the What's New. And if you don't have access to that either, just let me know and I can send you the What's New document on SpaceClaim. Hopefully, back over to you now, Peter, and you can go through the discovery highlights.
Great, thank you. If people on the call are SpaceClaim only customers, Discovery is basically effectively an add-on to SpaceClaim, which is incorporating simulation inside the product. If you don't have a simulation interest, you might want to hang on and see Tim's demo. It's basically also a foresight into the direction that SpaceClaim will go longer term. No major rush on this. It will take us a little while to port all of SpaceClaim across to the new style of interface, but the new style of interface you'll see is the same ribbon tab that you're familiar with SpaceClaim, but where the rest of the graphical user interface was panels, like the structure tree was in a panel, you'll now see the structure tree being inside the graphics scene. And then some of the controls, as you can maybe see in that top right-hand screen grab, you've got heads-up displays giving you access to the pull command and move command and views and stuff like that. Our plan, just for your awareness, it's going to be 12, 18, 24 months transition stage, but probably Ansys will be delivering both products to clients earlier than the completion of the tool. So for any of you Discovery users, you've got Discovery Live first, and then Discovery has been a replacement to that product, but both products are supported and delivered to a client, so you have plenty of time to review the capabilities and decide whether the full capabilities there or not. So any SpaceClaim customers, if you want to bear that in mind or ask Tim and me any questions, please let us know. For those of you that do have Discovery, obviously you can see the bullet points here, and we'll quickly run through the slides and show you the highlights that Tim and I have thought were the most relevant. Again, the list is typically 2 or 3 times longer than this. They were getting down to fairly minor enhancements, so we just picked out the ones we thought were most relevant. So Tim, if you can press the next slide. So the main bit of enhanced simulation capability is to do conjugate heat transfer, where you're combining fluid, solid, and thermal simulation in one. So in essence, a multi-physics type process. This is just in the refine mode. For those of you who know Discovery, you have a explore mode and a refine mode. Explore mode is the GPU powered simulation. Refine is the CPU traditional simulation process of meshing and simulating. So not as fast, but potentially more accurate or more control over the things that you might want to define. And conjugate heat transfer is a relatively involved calculation process. So it's just within the refine process at this time. There's also some enhancements that are listed here for productivity and automation features on this slide. So we're automatically defining the physics regions and grouping those within the physics tree, pretty much like your structures tree in SpaceClaim, but it's a physics tree, so that now that we've got multi-physics, it groups the constraints or the settings that you've got for the thermal and the fluids, so it just gives you a little bit more context. So that's quite a nice enhancement to be able to understand and read things more effectively. Next slide, please, Tim. In the GPU mode, in the Explore mode, the way the GPU mode works is it segments the volume basically into a voxel of 3D cubes, and the granularity of the calculation is dependent on the voxel size. Voxel size is defined or influenced by the amount of GPU video RAM you have and the number of cores. And that voxel size really gives you that that understanding or that realization as to whether your simulation is going to be captured at a fine detail. So on the left-hand side, you can see the size preview icon is switched on in this case, and it will show that your voxel size for this particular example and the machine it was run on has a granularity of 1.41 millimeters. So any geometry smaller than that may not get the physics or won't get the physics captured in a way that you should be assured. Resolution is on the right-hand side. That actually, if you click that on, highlights everything in red that isn't captured. Now in this part, you can see there's loads of lines. So along the edges, you're not necessarily going to be reliant on the exact stress calculation on that very edge. But all the planar information and all the surface data, the stress representation should be very effective. So just gives you some context as to when and where the accuracy of the GPU mode can be relied on. Next slide, please. Plenty of customers asked about this. Obviously, if you're producing simulation results, you may need to share or document that input or that creation. So they've implemented what appears to be quite a nice report generation method, where as you can see in the main drop-down window, there's a create report. If you just release on that, it will document and write out to HTML or Word the various settings, the name of the project or file name that you've got, date timestamps, the release version you're releasing, an interactive 3D graphic scene capturing a snapshot of the graphics, what your structure tree is, and the definition of the materials that you've selected with their various characteristics. And if you've got measurements, monitors, calculating output results, then it will document those as well. So nice bit of capability. Have a play of that if you've upgraded that release. Few other usabilities in the way that SpaceClaim does drag and drop. That's now been implemented. So you can just use a file browser and drop files on. Although slightly different here, you can either insert, or it will prompt you for insertion or dropping. Again, SpaceClaim operates in a slightly different way. If you drop it in a scene or drop it on the toolbar, it'll either open a new document, or it will insert in the current document. The heads-up displays of, sorry Tim, there was just a little bit more on heads-up displays. Heads-up displays have been enhanced. They were fairly static before, and if they were in the way, it was a bit of a problem. You can now easily select them and move them, or there's controls on the options to have different styles, and you control the sizing of the HUDs depending on your own maybe visual requirements. So useful enhancement, because it was a bit annoying when it didn't align as you might prefer. Thanks, Tim. And again, similar enhancements to the monitors, more options for calculating heat flow and heat flux. You can insert a specific datum point. You could only take monitors from surfaces or edges, but now you can actually use the, in essence, like the point symbol that you have in SpaceClaim. You can define that on a particular position, and then that will become a point that you can calculate a value and evaluate a specific point dependent on the average across that region or something. So good enhancement for that as well. Thanks, Tim. And for the refined mode, Convergence is for simulation people. They typically want to know when their calculated result can be relied upon. So convergence is the typical method for doing that. Basically, as you can see on the right-hand side, as your graph starts flattening out and aiming for a particular value, you can be assured that you're not going to get any other change to that calculation. You can rely on that calculated result as your final result. So that's been enabled, allowing people to work out when they should take their values. Again, refine mode isn't as relevant for the explore mode. But if your simulation runtime is going to take 10 or 20 minutes, you want to know when you can stop the iterations so you can just end the simulation. Thanks, Tim. Next slide. Few additions to, say, defining parameters. So they've added the fact that you can parameterize the numeric inputs for the physics conditions. So if you wanted to have a range of flow characteristics from 0.1 to 0.9 kilograms a second, you can now set that. You couldn't do that before. Sorry, the images covered up a bit of text, but basically it just gives enhancements to the design studies that you can run. So that was pretty useful as well, because there were some missing values that you could set. Thanks, Tim. And then one last thing, the monitors, you can export the monitor values to CSV. Again, in the report generation that we showed, it will put those monitor values in, but you might want the whole graph of data values put out. So that detail is also supplied and supported. So I think in the top right here, it just shows you how to hover over your particular monitor and export or show the data in a chart. Thanks, Tim. Do you want to run through those and present those?
So yeah, on to Discovery. I'll just be demoing a few of those features that Peter's mentioned. Again, there is a big list of new features, so I'll just hopefully run through as many as I can in sort of 15 minutes. So again, the first one is the drag and drop support. You can drag and drop support from Windows Explorer, your browsers, emails. So just to show you how that works, you can drag and drop it, insert it if you're already working with a file, so to add it to that file or open it in a new file. And this is just a very basic model. You'll have probably seen this before if you've seen Discovery or Discovery Live. So I just want to just go through a few of the new overviews, new HUD displays, and improvements to the overall sort of user interface. So if we just set up I'm in the Explore mode, so this is going to be using the GPU. I'm just going to just very quickly set up a simulation. So I'm just going to just set that as a fixed support. And sorry, I didn't tick that, didn't tick the box. Just select that again. Make sure I tick the box this time. And as you create your simulations, you will see everything appear on the left-hand side of your physics tree. And then I'm just going to just do the same for that area there. And then I'm going to apply a force to here. So this is one of the new features. Previously, this whole area where you get your sort of results or your settings, sometimes it could be overlaid with the model, or it was in a position where it wasn't nice to view it and that sort of thing. So now using this little tool here, you can actually drag that and drop it to a more convenient area if it is overlaying with the model or in a position where you can't see certain things. So that's one of the new features. So that's one of the first ones. I'm just going to add a 200 Newton force in this direction and make sure I change that to 0 and apply that. So I've just got some fixed supports in the force. We can literally straight away simulate this, solve this. And one of the things that Peter was mentioning was the sort of the resolution, and so now in the fidelity bar down below, you can also see, depending on what fidelity you've got set. So I can see here I'm putting quite a low fidelity at the moment, but my minimum feature size there is telling me is 0.47. Obviously, as I increase my fidelity bar, I'd expect that with that minimum feature size to decrease. So in a second, I can see now that my minimum feature is 0.32. So that's obviously that new feature is you can obviously physically see the minimum feature size if you have and that'll depend on a numbers factor. So that could depend on one, your graphics size and also graphics card, sorry, and also your model size really in the Explore mode. So if you've got a really large model, your minimum feature size may be slightly bigger, but if you've got a really powerful graphics card, you may be able to get minimum feature sizes a lot lower. So also just to see here, you've got your resolution tool and your size preview also here. So those are those two new features, and also in your fidelity bar, if you hover over it, you'll be able to see the minimum feature size. So I just wanted to show you those two things. Next, let's have a look. One another new feature. Let's just see if we can get some results. Let's solve that. Wait till this solves, because another new feature is the results themselves. So previously, the results that you displayed couldn't be controlled, the units couldn't be controlled. So now they can, so you can see here at the moment I'm displaying my units in meters. I can change that to different units of my choice, for example, millimeters. So that's a really nice new feature. Obviously, it wasn't added in the first release, but has been added in the second release. So depending on what you've got set, let's go to stress. We can visualize different units depending on your settings. So I just wanted to show you those new HUD features there. I'm going to now just go through a simulation sort of from start to finish, which will hopefully show a couple of new features. This will be in the refine mode. So if I go to open, and actually go to the home page. So this is a fluid solid thermal, or CHD, simulation. So imported the model. Again, you've got your structure on the left-hand side. You've got your 4 components, 3 and the base plate. So to set up a fluid solid thermal, it's basically going through it step by step. First thing to do is to actually create a volume, extract the actual volume area, fluid volume. If you ever click on a model, you can always make it transparent using this little tool down below, so you can see where my fluid volume should be. And to extract it, in the Prepare tab, I've got a great tool for extracting volumes. Literally click a face, click a seed face or an internal face, hit your tick box, and we'll create the volume. And we can see here in our tree, we've got a new component called volume. From there, we can literally, next step, because we're doing a fluid solid thermal, we need to have the imprint of these faces on the base plate, which we haven't got at the moment. But again, we've got a very automated imprint tool. You'll see the preview, hit the tick box, and that is literally done. So if I just hide that, you can see the imprint that we've got there now. Now we can start setting up our simulation settings. So in this instance, I'm going to do the fluid first. So I'm going to click on this face, click on my wizard bar, and choose a fluid flow. And I'm just going to choose a value of 1 meter per second with a temperature of 30. And hit the enter tool. I'm going to choose this face as an outlet. And I'm just going to hit the tick box. So I've set up my fluid properties. Next thing I need to do is set up my temperature properties. So these components, I'm going to triple click on them, and that should select the whole solid. And we can always see down here that we've got the body selected. And I'm going to set up a thermal property. I'm just going to set up a heat of 100 watts. And as we add stuff, we can see it appear in our tree as well. So we can see I've got heat 100 watts. So I'm going to just triple click on this one and hit enter. So I can add a heat to that, and triple click on this one, hit enter, and add a heat to that. So that should be enough. One last thing, I want to add an insulated face to this bottom face. So I can either do that in my wizard bar here, or I can go to my simulation tab at the very right hand side and click on, I've already selected the face, so I just want to insulate that, make sure that face is insulated. And then you can see that that is now added to my physics. So did I click it? Did I click the tick box? Right? Let's make sure I did. Yeah. Oh no, I didn't. So there it is. So I'm just going to hit escape twice, and basically this is now ready to be run. If we hover over, and I'm going to make sure I'm in the refine mode because this can only be done in the refine mode, and this is using the CPU rather than the GPU, so it does take a little bit longer. If you hover over the HUD, the heads-up display here, you can see which areas are going to be defined for what. So as I hover over the fluid area, you can see it highlights and the solid area. So pretty much going to hit the play button or the solve button, and that will start solving. And again, this is based on a fidelity that I've got set here, so just like a mid-level fidelity, and it will use Ansys' automated meshing to define a mesh. But please remember that you can also define the mesh manually. You don't have to go, obviously you can increase the fidelity bar, but you do have your local and global mesh settings here. So you can use those to define the mesh yourself. As this is solving, you'll see like the sort of green bar appear. So that's sort of your progress bar. So as that gets closer to fully green, you'll know that your part is about to be solved. Once it's got to about halfway, you will actually be able to show the mesh. So the mesh is actually visible. So I can actually tick the show mesh tool here, which will basically just give us a visualization of the mesh that we have. So hopefully you can see that. This simulation should take hopefully no longer than another 30 seconds. And then I will show you the reports and exporting monitors to CSV and that sort of thing. So if we just wait for hopefully no longer than 30 seconds, we should see some results start to appear. Normally that green bar, it's not really, can't really time it, so I wouldn't say this is halfway at the moment. I'd say it's probably further than halfway, and you will see the green bar sort of just shoot round hopefully in a second to simulate this. Obviously it's doing on the CPU, so again, it will take a little bit longer than the GPU's solvers.
You should have done famous Blue Peter style and had one ready.
I should have done, yeah. I did run it previously, and it did only take like a minute, so I thought won't be that too bad, but it we should get some results in a second.
While we're waiting, does anyone want to answer any questions? You just have to unmute if you do want to pop up and say anything. Dave.
So it looks like it's nearly done. Okay, so yeah, looks like we're starting to get some, we have got some results. So the initial results we're showing is temperature. Again, remember you can change the value, we're looking at 3 Celsius, you can change the Fahrenheit Kelvin. And just visually looking at this part, we can obviously see that the third component is obviously a lot hotter than the first two. So we could change it here to velocity. We can see sort of why that is happening. So we can see that the fluid flow obviously decreases as it gets to the third component. So you could obviously modify your physics setup, or you might want to actually go and modify the actual model itself to try and increase the fluid flow to the third area to obviously get better results. So it's actually cooling that third component a little bit better. So you've got your default monitors. So these are just your max temperature, pressure drop, and max velocity. So these are just the default ones that show up. You can create as many monitors you want. So you've got the monitors here. So you can also create these ones, or you can select on your wizard and you can create a calculator via here. So you can find out, as Peter mentioned, like specific temperatures or on a point or on a face, that sort of thing. So you do have a lot of control over this. Exporting the monitors to an Excel file, very easy. Now you can right click on one of them and you can either export just that particular chart or all the chart data, and that'll export to a CSV file that can be opened up in Excel, etc. One of the other things that Peter showed in the slides was the report generation. So if I just quickly show you that, basically from the file, top left-hand corner, you can go to create report, and it will save it as HTML. So just type in discovery, save it, and this is the sort of thing that will appear. So it's HTML. This is actually a 3D model, so you can actually rotate the model around. You've got your geometry, and then it will basically show you all the monitors that I had set up there. So obviously I only have pressure drop, max velocity, and max temperature, but if you have more monitors. And again, this data can be extracted, and you can build up your own reports in Word or PowerPoint if you don't want to extract this data very quickly. Lastly, if you want to take images from Discovery, again, similar to SpaceClaim, you can right-click, copy scene, and those images can very quickly be used in, for example, email, just by copying and pasting them in, or into report generation, if you want to put more images into your report. So that is just a few of the new features in Discovery. As we mentioned, there is a lot more, so please do look at the What's New guide. And if you do have any questions on Discovery or SpaceClaim on any new features or the program in general, please don't hesitate to ask myself or Peter. Do you want to add anything to that, Peter?
Only Nick's asked a question.
Sorry, no, I can't remember.
Sorry. Can you comment on the materials library, special infrastructure, on how to add new materials?
Yes. So at the moment, this is just a default material, structural steel. If I want to change the material in this model, obviously got 3 components. Easiest way to do it is to triple click on a part, and I can go to my material, and then I can search for a material, or I can add a material here. So I might want those to be copper. So now my part is structural steel and copper, and you can hopefully see the sort of color definition has been changed. So that's sort of a copper color, and this is structural steel color. So it is very easy to actually change the materials, and we can see you can choose a big list here. You can actually create your own materials as well. So if I wanted to create my own material, so I can see I've got that one as copper and this one is copper. Make sure I've got the body selected, and you can choose a custom, so user-defined solid here, and you can basically set up your density and in this instance density, thermal conductivity, and specific heat properties. But depending on your what sort of simulation you're actually doing, you can obviously have more properties. So if it's just purely a structural, the materials have more properties, and the materials. There is add-ons to this, so you can actually get full access to, which Peter might mention, to Granta materials.
Yeah, that's just for floating customers at the moment, unfortunately.
So yeah, so if you have got a floating license, you actually can get access to a larger library of materials, but you can create your own, and there is a fairly decent library already in the software. So that's how you assign materials and create your own.
Any questions from anyone else? SpaceClaim from the first part, or obviously anything else on Discovery? Because we've done 50 minutes, so I want to try and keep to the time. If anyone wants to email Tim and myself, Tim, could you just bring up the first slide on the Power Deck so they can see both of our email addresses. If you've got any questions, feel free to email myself and Tim, or one or the other, or obviously get in contact if you want to have a chat. Happy to phone you back. Discuss any aspects you've got. So thanks very much for attending today, and don't be shy if you do have any questions. Have a good afternoon.
Cheers,
Thanks, Tim.